Good evening. I am Abhishek Kumar. I am an Institute Geology from Information College. I am making this video as a presentation of my market practices PPT presentation. My topic is parts of the rig. So let's begin. So an oil rig, understanding an oil rig just first in just few sentences is very complex. It's a big structure. Oil rigs have evolved over years. It's an engineering marvel. So to explain you the concepts, I have tried to break down the oil rig in some parts based on different functions. So these are my parts or components as you need to call them. We will look after them one after the other as we proceed. First is the power system. So for doing anything we need energy. So our oil rig will be powered by uh, whatever fuel generates diesel. It gives more fuel, more energy. They are they are kept over here. Fuel is stored somewhere apart from the rig, so obviously it's inflammable. It should be at a safe distance. There are engineering engines and generators which will give the power to the rig and various other equipments on the rig. So this is a schematic diagram of the oil rig. On this is basically for land, but on offshore and floating rigs also it is just the same, just the substructure differs. I will tell you what substructure is. So let's proceed. Then we come to some miscellaneous rig components. So basically you have first the driller's cabin here, right here. Now the left. Let's go to the options. Okay, I hope my mouse is visible. So for some miscellaneous rig components, uh, this is the doghouse or the driller's cabin where the driller or the mud logging data comes. Basically, where the driller has all its equipment of this. Then this is the substructure, the legs of the rig on land. If it's offshore, it could continue to the seabed, or if it is floating, there may be some part of leg and other. Then you will have some propellers and every all other mechanism. Then the whole main structure of the rig is called mast or derrick. There are some basic differences. Then we come to monkey board. It's at a distance at a height of 90 feet from the rotary table. As you know, rotary table on the rig is the reference line for all our depth readings. Then we come to the, the mechanism or storage areas or the area for pipes, wherever the pipes are kept under. This is pipe rack. Here we keep our pipes or casings, whatever may be needed. On land there is plenty of space generally, but on offshore rigs we have to compromise with the space, so everything must be planned accordingly. Then you pick the pipe racks from here, put it on the, it passes through catwalk, just basically the path for pipe. Then it goes up to the rotary table or the actual drill floor through pipe ramp or what we call V-door. Then some other parts. Uh, First we have driller's console, where the driller will control of the how much weight he have to transfer on the boat, how much to keep on the hook, so not to get damage the bait, get the most efficient drilling speed and other parameters. Then there are indicators for various parameters. Then there are slips. You may see them. Slips are used when it was used in past when there was Kelly system. So it's used nowadays also when you separate the drill string or casing string from the Kelly or top drive. You have to like the caliper above. You have to keep the drill string attached somewhere, like on a hook. So it's like a hook on the drill, drill floor where you hang your drill string basically. So it goes around here. It is pushed by three drillers by the leg, and for casing, in case of casing, the slip is called spider. Just have a weird name for the parts of drilling it. Then here we have rat hole. So rat hole is a designated place where you can keep your cali when you have to uh, remove the cali from the hoisting system. You can put your cali here. For example, when you have to add a new drill string, then you can keep your pipes, uh, your drill pipe, available drill pipe or driller collar in the mouse hole here. You can keep the pipe here from the pipe that can meter and cap over here. So you can just pick it up and join it whenever there is need and you have to certificate. Let's move on. Now comes the hoisting and rotary system. So we will just do it. Carry carrying forward. Hoisting and rotary system. We will start from drawworks. Uh, so we must understand that we are getting our drill string, and on the bottom of that we are attaching the belt. So obviously for going down you must push from top, and it's not just like my hand or a bottle which you can push from your hand. It's a massive structure, so for that you can use some physics basically, and so we have developed the pulley system over thousands of years, hundreds of years at least. So yeah, let's start from drawwork. A wire goes from here to the top of the mast rotating, which is called the crow's nest crown block. It has various pulleys. It is a multiple pulley system, and pulleys are called sheaves. And from there, it goes down to the traveling block, and it may wind around it. Is uh, the metal wire will go 4 to 5 times or 6 times, 8 times, whatever the pulley is built to. It varies from big pulley. It will go around this for 4 to 5 or 8 times, whatever. And below the traveling block, we have hook, and below the hook, you have the swivel, or yeah, you have the swivel, and beneath that, your cali is attached. In older drilling system, cali was used. Nowadays we use top drive. In top drive, you don't have swivel because means if you have top drive, then swivel and cali both are replaced by top drive. So there is only one equipment. And as we know, because top drive provides rotation also on its own, which the cali could not. It was old, and obviously newer technology, the top drive replaced it. Moving forward, we have cali bushings. These are at the bottom of the cali. We have some four rotating fingers like this. It will go and fix in the master bushing in the rotary table. And what used to happen earlier was, I told the cali could not produce rotation on its own for the drill string for the bit to cut more efficiently downward. So we used to fit the cali bushing in the master bushing in the rotary table, and then we will rotate the rotary table, and that will rotate the cali, and obviously the drill string attached to it, the subsurface. Okay. Now moving forward. Yeah, I guess I covered everything. Yeah, in Calicut was generally 40 feet, so it would come somehow nearly approximately equal to the stabbing board, which is where a drilling crew member will be there in case of casing the well. A casing unit is around 40 feet. That is stabbing board somewhere here on the top. Now, you can see this monkey board. Moving forward. Yeah, this is a closer look, traveling block road, and just you can see that the swivel elevator is the part where we attach it to the pipe, the drilling pipes. Okay. Next we come to mud circulation and mud cleaning system. So yeah, basically first we have a reserve pit. Here all your mud with cuttings will come, which has to be disposed of or which you don't need after you have collected the cuttings. Excess will be thrown here. On land, it is generally made by digging up a hill, covering it with some plastic or water or impervious layer to stop it from going underground and damaging the aquifer and natural environment of the plants and animals. Then we have water tanks somewhere. It can be anywhere, like if not near the float, it can be far away but far. We have water tank where to have for other use on the rig. People basically live on the rig on the in the course of 21 days. Their 21-day shifts. We have mud house where all the components needed for making the mud, bentonite, mud monoamide or perite or anhydride cement, whatever you add to it. Then you have a bulk mud component storage where you can store the additional mud, and it can be used sometimes when there is excess loss downhole. Now here you can see the set of mud tanks. You probably specify these are mud tanks. From mud tank is where the mud will be kept. It will have agitator to keep the mud moving so it doesn't just form a glue-like structure, so it don't solidify it. Uh, then we have mud pumps. These will pump the mud. They take it from the mud tanks, pump it. Mud pumps can be two to three or four, whatever, depending on the rig and its size. Mud pumps can be duplex or triple depending on whether they have two or three pistons. From there, the mud will go through the surface lines. It will travel through the stack pipe manifold to go to the mast. From there, it will go to through a rubber hose to the goose knob on the swivel. From there, it will go down the drill pipe, the drill string. It will flow down to the angle, flow down to the well bottom, pass through the bed, carry the cuttings upward, or at least force them, travel all the way back up to annulus, and then back it comes back to the surface to flow line. From flow line it will go to our shale shakers. And shale shakers are, as you know, is the most important part for a geologist on the rig. We can say it is the most important component because from here we get to collect our cuttings from down here and cutting and there will be gas also in the well. From the cutting we can get to know about the condition of the well, the downhole ecology. So as our sir always say, it is basically like the pulse of the well we are drilling. So you can get the vital stats about the well from the shale shakers. Here obviously you have shale shakers which remove the cuttings, the bigger cuttings. Final cuttings obviously go below it in the center. You have possibly also in the shale shaker, and there you can install the gas detecting material, gas equipment to detect the gases. But I won't go over that. Moving forward, we come to vacuum degasser. Here, if they are, we come back to vacuum degasser. We come back to vacuum degasser. If there is any trip gas or minute amount of gas in the mud, this will remove that. And we have to be careful about the degasser. There are like two degassers on the rig, at least two degassers. So this is the vacuum degasser. It is the part of the mud circulation and mud cleaning system. Moving forward, we come to descender. It removes the sand from the mud which was not removed in the shale shaker as the mud size is smaller. They use cyclophones to they use the principle of centrifugation and centrifugal forces to separate the contents. The sand goes to one side and mud will flow out. The same goes with Desilter. It separates the still smaller particles, same size, and it comes back to the mud tank. Again, it is agitated and completely mixed. It is like a cycle. Moving forward, one of the most important things, the well control system. On rate, safety, yes, the profit making and money is a big factor, but yes, safety is more important. There is nothing important in safety in the way. So obviously the crew follows everything. Even when you go upstairs or downstairs, you have to hold the rig handles proper, the stair handles properly. Uh, one hand for the company, one hand for you. That's it. So well control system to prevent any kicks and blowouts. First, mud is the primary well control system, but in case mud fails to keep the well proper from functioning properly, and there is a inflow, there is a kick, then we must use second. We must proceed to secondary well control system. For it, first you must understand the accumulator unit. Accumulator unit is like a powerhouse for pressure, which will ultimately go to ramps in your view. So the accumulator unit uses enterogen nitrogen gas to build pressure and close BOP ramps, whichever pipe ram, shear ram, or blind ram, whichever when needed in the case of a blowout or inflow. Okay, you have the BOP stack, blowout preventer stack, which has the ramps, pipe ramps, shear ramps, and blood ramps. Blind ramps. And BOP stack is always installed above casing. So whatever casing you are running from downhole to the surface, casing always go from downhole to the surface. So all the casings have to be nippled up to the BOP stack. Uh, yeah, that's it. Then the BOP stack has mm, connection for kill line where you can supply the kill mud to kill the mud in case of inflow or increasing gas pressure or fluid formation pressure. And you have a choke line from where it will go to choke manifold to control the uh, gas fluid and pass it slowly so there isn't much damage. Here is the choke manifold. Choke manifold is a complex system of pipes and valves. It can contain can withstand high pressure. So from here, the gas fluid is slowly released to further control our well. From there, travel to poor boy degasser or the atmospheric degasser, or in short, it is called MGS, that is mud gas separator. Here, it is also again a complex, not so complex, but it is an equipment which separates the mud from the gas using various slanting. It's like slanting slab structures inside it, and it separates the. So if the mud with gas falls on it, mud travels downward, gas goes up, and it is sucked out. Uh, the gas is taken away from the rig on the land, and it is flared away, burnt away some 1 to 1.5 kilometer, depending on whatever the distance is. On offshore or floating rigs, we use flare booms. There are generally two flare booms in opposing direction based on the wind direction where the wind is flowing. You burn the gas on one of them so the flame doesn't come to the rig at hurt. This was used earlier, but nowadays again we are facing a lot of environmental problems and all, and it will aggravate the climate problems, global warming. So nowadays it is banned, and we might just dispose of the gas using some other ways instead of just burning. So yeah, after that, once you get the control of the mud, control of the well, then you deal with the heavier mud, and you continue with the drilling. And yeah, whenever there is some kick or inflow, only the crew members which are very much needed to control the kick or flow out only kick then only they are only present on the reef. All others are sent abroad. All others are sent away or evacuated to safer area. So in the case of a blowout where the kick cannot be controlled, the that is the info cannot be controlled, so there is a less loss of life. Uh, yeah, so in this way you can control your well. So that's it. These are my references. This was in obviously in short. I like you can study every component in like for hours, and it's really amazing. These are my references. Thank you. You may ask your questions if you have any. Thank you.